but also from some open source projects. At the end, I will give you another advice how you do it better. So the first approach is the string and deny input approach. So I'm calling it like that. So this means if the data contains bad character or bad word, we should not process the user input further. And what happens, we just send an error message. Or if we are relying on the .NET framework, we get an HTTP request validation exception. This is something that I do not see quite often. I guess this is not very user-friendly, and I also saw some web application firewalls that were just only in passive mode, but this is just a joke. The next point is the substitution and continue approach. So if the data contains any predefined bad input, what we should do, we usually strip it out or replace the data with other harmless data. And afterwards, we proceed with the new validated user input further. This is something that usually happened, maybe because it's very user-friendly and because we don't have to care about any error messages. And for the developer side of view, it's also very simple to handle it. So the next approach is done by regular expressions, and I'm calling the seek and destroy approach. What we are using is the same basic approach as before in combination. And this is usually the de facto standard solution. So, and we're using here the regular expressions as the Swiss Army knife for everything, for every input validation in general. So, if you're aware of the Owasp anti-SEMI project, anti-XSS SEMI project, then you will see that there are a lot of cross-site scripting prevention mechanism implemented through regular expressions, and also the brand new Beta 2 from Internet Explorer version 8 has also implemented a lot of regular expressions, which hopefully suffer you from XSS. Something?
Yeah, I just need to charge it because we have another
presentation.
Sorry.
Just take it. I think this is mine, yeah. Okay. Never mind. So what's the pitfalls about these approaches? So first of all, we have to define the bait data, right? And now we're discussing the pros and the cons of each approach. So the string search and deny input approach is first of all very easy to implement. Yeah, and deny is always good to have it. On the other side, we have to define what kind of data is bad, and this is usually based on the user experience. And on the other side, we know also the bad list is by definition not complete. And also usually, if I'm doing it via string search, these kind of characters or words are case sensitive, which is also not so very good. And we also have to think about canonicalization in this point if we're dealing with characters from Asia or other countries or continents. So on the substitution and continue approach is first of all quite easy also to implement, but is already very user-friendly for the data flow, for the application. And we have, again, the same disadvantages that we have to define the bait data. And yeah, in the next point, we should, or we could also substitute harmless data in any point, which maybe affect your logic business, the logic business of the application. And we also know in general that data correction is prone to security issues as well. So just be aware of it. And also there are some other needs, kinds of possibilities, which I'm discussing later, how browser are handling different kind of specific characters, not like null bytes, etc. So on the next point, we have regular expressions. In general, the pro side we have the same one, and on the contra side we have the same problems as before, but we should know that to write a regular expression could be a really great challenge, depending on what you have to do, and also regular expressions leads to logical flaws. So my question is, do you know the match only at end of string modifier, which is part of the zero wizard section? Somebody is here who knows this? Okay. Okay, so just an example. This is Perl, and this is our whitelist. We are searching from the beginning of the string to the end of the string that we are allowing just only lowercase alpha characters. So, but what we are giving here is also at the end a new line character. So my question is, what do you think is the result now? Is it true or false? Okay, who is for true? Raise the hand. Who's for false? Okay, cool. It's true. So why it's true? Because of it's matched not really at the end of the string. Yeah? So if you want to do it like that, you have to use another modifier. On Perl, it's set, the small set. On PHP, I think it's the uppercase D. And only this modifier looks really at the end of the string. So, and this quite neat example demonstrates you how sometimes you can bypass also a logical, very good cross-site scripting filter. Depends now afterwards what's happened with the data. Yeah, but this kind of regular expression could lead to other vulnerabilities, SMTP injection or HTTP response splitting and so on. So what kind of evasion exists? So for my experience, I just put it into 3 categories, or to 2, and I split it again. So first one are technical based, and the next one are human based. The technical one, I just split it up into logical flaws and third-party issues. So what is it exactly? So the logic flaws, I put everything that I mentioned before on the disadvantage side from the filters, from the basic approaches there. So we can miss a bad character or words. This is something what can happen. We can also use a wrong regular expression, or use or forget about one modifier. We can also do another fault. We elect the wrong regular expression library, and I will demonstrate it later on the example section. But there are also some other